So we concluded the other day talking our discussion about mechanical weathering with this topic of exfoliation and how once these top layers start to whittle away, then we get this outward pressure and the cracking of the rocks to create this sort of like dead skin type of outside of these rocks that can get easily weathered away. Now we're going to shift our focus over to chemical weathering. So that's the second type that we introduced the other day, but we're going to focus more in and completely on chemical weathering today. So there are a couple main agents at work of chemical weathering. Of course, they include water. That's the title of our unit and really the purpose we're talking about it. But also oxygen and more importantly, what oxygen mixes with, and also acid precipitation, or as you might have heard it, acid rain. So these factors can change the rock's composition. This is the big one. This is what the rock is made of. This is our big difference between physical and chemical changes, the change in the rock's composition. And it can also be influenced by temperature, as we saw in our lab yesterday, and of course, what the rock is made of. That's our definition of a chemical change. So what is the effect of water? Water is weird, right? We've been saying that this whole unit. Water has lots of special properties. And part of what water is so good at is dissolving lots of different things. In our Engage activity, we looked at a sugar cube and granulated sugar and how they dissolve at different rates in water. But if you keep stirring, and actually if you start to mess with things like temperature, stirring, speed, you can actually change how much is dissolved, and eventually you would see that all of the sugar would be dissolved. And this one's kind of strange. It can serve as a medium or a place for minerals to mix. So if I take mineral or substance A and mineral or substance B and mix them together in water, sometimes those things can mix together and create what we call precipitates or different solids that can only mix in water. So they sort of need this area to mix, and that's one of those key factors of water. But then also it can react directly with minerals. So for example, if you take pure sodium and you put it in water, you're going to have quite the reaction where the sodium might end up exploding just because of the reaction directly with water. So water plays lots of different roles. It can be this medium. It can also react directly with minerals, but also can dissolve some things as well. So on the right side of your notes, we've already talked about sugar. That's the easy one that we've talked about together. So I want to see if you can come up with at least two substances that can dissolve in water. If you think about it and think about food or maybe drinks, I bet you can come up with something pretty quickly. So let's try to get two things on the right side of your notes of substances that can dissolve in water. So moving forward to talk about oxygen, the big one and something you'll hit in chemistry is what we call oxidation. So that's any chemical reaction with oxygen or other substances that creates this new oxidized element or oxidized compound at the end. For example, we look at iron a lot in the field of geology, and it's very, very obvious where iron is because we can tell by this brownish reddish color. That is iron oxide, or in terms we might be familiar with, rust. So same thing with your car too. Our cars are exposed to lots of changes in temperature, lots of water, lots of oxygen, of course, and lots of salt from the roads in Minnesota. So that can actually cause our cars to rust. So the metal that the car is made of could be oxidizing to create this iron oxide, this rust down below. And another thing in addition to iron is also copper. That's why sometimes when you look at a really old penny, you might see some sort of like greenish stuff in there. And that's the reason that the Statue of Liberty is actually this greenish color. It's because it has been oxidized. It's gone through an oxidation process. So if you look back in the 1800s, when we received the Statue of Liberty, that's what it looked like. It had this copperish, brownish red color, but since it's oxidized over time, now we have this kind of bright greenish color on the right-hand side. Kind of interesting. So the Statue of Liberty shows a chemical change has occurred because over time, the Statue of Liberty went from this reddish orangish color showing that that's what copper usually looks like in its natural form, and has changed over to this greenish color. So definitely change colors over time. Now moving to our last topic of today, the effect of acid precipitation, or in other words, this would be acid rain, which you may have heard of before. The big culprit is sulfur dioxide. So this is something that comes out of factories. Sometimes in those plumes of smoke that you might see from factories, there could be some sulfur dioxide in there, but also CO2 and nitrogen oxide as well. So those can hang on to water in the atmosphere and sort of mix in the clouds to create slightly acidic rain. We're not talking about like stuff in sci-fi movies where you go out and all of a sudden your skin starts burning, but we're talking about very slightly acidic rain. And it actually has quite a similar effect to acidic water that we talked about in our last unit. So you can see here, this is a great example. These pines here just look a little bit weaker than they might over here. This would be a healthy branch off of a tree. This one looks a little bit weaker and also kind of gives some coral bleaching vibes. That looks like it's just a little bit weaker, maybe not going to stand up to some weather that it might if it was healthy, stuff like that. So this can harm the growth of organisms, so it can stint the growth or maybe cause some of these leaves to die out, like in this example over here. But it can also make trees and other plants more vulnerable to disease. So think about it in terms of humans. If you're not healthy or if you're not as strong, then you're obviously more vulnerable to getting sick or a weakened immune system or something like that. So very similar here, just slightly acidic rain that can have quite the negative impact on our plants. This slightly acidic rain can also dissolve things like limestone and marble. So marble is just the metamorphic version of limestone, going back to our metamorphic discussion from 8th grade and maybe even 6th grade there. But it can actually start to eat away at some of these organisms or some of these rocks that have calcium carbonate in them. So that's thinking back to our last unit, talking about those shelled organisms or the rocks that contain limestone. And what we see a lot in Minnesota is actually stuff like this, what we call karst topography. Because a lot of our bedrock is limestone in Minnesota, lots of it can get eaten away by this slightly acidic groundwater or water that's running under the surface of the earth. So this can create caves. It can also create sinkholes. If we have a bunch of grass on top over here and all of a sudden we have a cave, well, eventually this is just going to cave in and we'll get a sinkhole in that area. So any leftover CO2 in the soil can mix with groundwater to create very slightly acidic water, or that slightly carbonic acid that we talked about in our last unit, to actually carve out caves and also cause sinkholes. So on the right side of your notes, this is going to take us to our end, to the end of the video, and then we will move on to rate of weathering next week. It says circle which would not be an agent of chemical weathering. So based on what we talked about, which one of these would not be an agent of chemical weathering? And then finally, express in your own words the effect that chemical weathering has on rocks. So you can go back, think about limestone, think about the different types of rocks that we've talked about, even marble as well, and express in your own words what chemical weathering can do to those rocks and some possible impacts as well. So that concludes the chemical weathering portion. Make sure you have your readings done from this week, and then we'll move on to rate of weathering next week.